Section 4.3 is called the triangle inequalities. So why is it that that bottom middle can form a triangle, but then off to the far right we can't make a triangle with the green and two yellows? Well, the yellows are too short, right? They'll never meet to build a triangle. And so that brings us to the triangle inequality conjecture, which states the sum of the lengths of any two sides of a triangle must be, how are they related to the third side? So a quick demonstration, let's take 1 inch, 1.5 inches, and 2 inches and try to build a triangle with it. So with my compass and straight edge, I'll copy 2 inches. I'll grab that 1.5 inch length with my compass. I'll apply that from the left-hand side. Grab the 1 inch, apply that from the right-hand side. And you see that we build a triangle with 1, 1.5, and 2 inches. Well, can we follow the same steps to build a triangle with 1, 2, and 3 inches? You can't do it. The reason why is it falls flat. Your 1 inch and 2 inch sides will never meet. So that brings us to the triangle inequality conjecture, which states the sum of the lengths of any two sides must be greater than the length of the third side. So a quick example, can we take 8, 15, 17 and form a triangle? Well, you could pull out your compass and straight edge to verify, or you can use the triangle inequality conjecture. Because the sum of the lengths of any two is always greater than the third, we know that 8, 15, 17 can form a triangle. Well, what about 6, 8, 15? Well, that doesn't work out because 6 plus 8, the sum of any two sides, is not greater than the third. So now let's take a look. Two sides, let's say, are 5 and 8. How long could the third side possibly be? Well, the third side has to be bigger than the difference, but smaller than the sum of the other two sides. So 8 minus 5 and 8 plus 5 give us these boundaries. The third side can be bigger than 3, but it has to be less than 13. Here's a multiple choice question for you. Give it a shot, push pause, try it on your own. Because the third side has to be in between the difference and the sum, we know that 25 has to be it because the third side has to be bigger than 14 but less than 36. So now a big challenge question for you. What is the area of a triangle with sides 24, 38, and 14? It's kind of a bogus question. The reason why is there is no such triangle. 14 and 24 are not bigger than 38. So therefore, this cannot form a triangle by the triangle sum conjecture. One last example, sort of throwing some algebra in there. Let's say we've got 2x plus 5, 22, and 13. And we want to figure out the possible values of x. Well, let's pretend like we didn't know 2x plus 5. We just say that the third side is between 22 minus 13 and 22 plus 13. So now if you sub in 2x plus 5, we have an inequality to solve. So the difference is 9 and the sum is 35. If you break that up into two separate inequalities, you can see that 9 has to be less than 2x plus 5. Subtracting 5 and dividing by 2, you get that x must be greater than 2. And likewise on the other side, you know that 2x plus 5 has to be less than 35. So that means x has to be less than 15. And we can bring it together and say, therefore, x has to be bigger than 2, but less than 15. Next conjecture is the side angle inequality conjecture, which states that the longest side is always opposite the biggest angle, and vice versa. So if we have a triangle, the longest side points to the biggest angle. And likewise, the shortest side points to the smallest angle. So again, to put a finer point on it, in this triangle, we see the longest side is opposite the biggest angle. The shortest side is opposite the smallest angle, and vice versa. The longest angle is opposite from the longest side, the largest angle, and the smallest angle is opposite the shortest side. Let's try a few examples. Take a minute and sketch this into your notes. Push pause if you need to. We want to put the order of the sides, put them in order from longest to shortest. So focus on the fact that we have two separate triangles. Let's start by looking at the triangle on the left. I see 65 is the biggest angle, so therefore AD is the largest side of the triangle on the left. The medium side tells me that AB is the medium size, and 55 is the smallest angle, so therefore BD is the shortest side of the left-hand triangle. Do the same with the right-hand side. I see 115 is the largest side of the right-hand side triangle. We've got my medium triangle, or medium side, and the shortest side. So the thing to recognize, I guess, is that BD is the largest side of the triangle on the right. It's the shortest side of the triangle on the left. And so that means that ABD, the triangle on the left, is the bigger triangle. So therefore, the longest side has to be AD, then AB, then BD, and BD is the connector. Right? What was the short side is now the large side of the right-hand side triangle. So then we'll work through the right-hand side triangle. CD is the medium side, and the shortest has to be BC. Turning it around the other way, I see 6 is the largest side, so therefore F has to be the biggest angle. 4 is the smallest, so therefore E would be the narrowest angle, or the smallest angle. And one final conjecture, the exterior angle conjecture. So draw yourself a triangle and then extend one of the sides. When you do that, you produce an exterior angle. The angles that are far away from it inside are called the remote interior angles and the adjacent interior angle. The exterior angle conjecture says that the exterior angle is equal to the sum of the two remote interiors. To put it more compactly, in this triangle, we would say that D is equal to the sum of A and B. And so, final example here. Take a minute and copy this sketch in your notes, and it's your job to solve for X. And that's a problem that your teacher will go through when you get back to class.